Alright, let me start by apologizing for this video. I am getting a migraine, so I'm going to do my best to get you these notes so that you can put them in your foldable. We are in this section called Rational Exponents, and you can have the sub pause this video whenever you need to, or you can rewind if you miss something or miss an example. It's also going to be on the wiki for you to watch, so if you miss something in class you can go home and watch it or review it. The first thing that we're going to talk about is called exponent notation. And this deals with radicals. And you can see in this example, b to the m over n is the same thing as the nth root of b to the m. So the number on top goes inside the square root. The number on the bottom is your root number. So the first few problems, all we're going to do is translate these. So a to the 1/4 becomes, is this all right? The 4th root, because that number's on the bottom, of a, and a would be to the 1st, but you don't have to write that exponent. So now down here with my second example, we have the 5th root, because that's on the bottom of that fractional exponent, of x, and x is also to the 1st, and since it's an exponent of 1, we don't have to write that. So that's how you translate from fractional exponents back into radicals. The next examples we're going to go in reverse. So if I have the cubed root of y, and I want to write that with a fractional exponent, I'm going to write y to the 1/3. The exponent on y is 1, so that goes on top of the fraction. The root number is 3, so that goes on the bottom of the fraction. Go ahead and try this next one. See what you can come up with. And the answer will be c to the 1/8. 8 is the root number, so it goes on the bottom of a fraction. The exponent on c is 1, so that goes on the top. You are going to have some problems in your homework where all you're doing is translating those. Now let's look at the next type of problems. If my screen will scroll. There we go. When it says evaluate, the difference here is we're going to have numbers. So we can actually take their square roots and their cubed roots and 4th roots. Whereas before the examples when we were translating, most of those were just variables. So we have to remember the rules with exponents. First thing that I see is this is a negative exponent. So that means to make that exponent positive, I'm going to move 16 to the 1/4 to the bottom of the fraction. Now I'm going to translate it into my radical. So it's going to be 1 over the 4th root of 16. Since 16 is a number, I can break that down into 4 and 4. Sorry about that. And then I can break the 4 and 4 down, each of those down into 2 and 2. My computer is being really slow right now. Alright, so hopefully you've been able to do this on your paper. And you can see that 16, the 4th root of that, we have 4 sets of 2. So the bottom is just going to become 2, so this fraction becomes 1/2. Alright, for my next example, this one's a little bit more complicated. we have the fifth root of 243 cubed. So you're going to take and first translate that into fifth root of 243 cubed. This 3 should be under the radical sign. Again, my computer is being really slow, so this video has got some serious lag time in it. We have the fifth root of 243 cubed. Well, we need to take 243 and cube it, and that's going to give me a really large number. So what I'm going to take is the fifth root of 243 cubed, so that's 243 times 243 times 243. It should be 243. Each one of those can be factored down into 3 and 81. 81 breaks down into 9 and 9. And that breaks down into 3 and 3. So each one of these breaks down into 5 sets of 3. Since it's a fifth root, I'm going to have 5 3s from the first one, 5 3s from the second one, 5 3s from the third one. Fifth root, I need sets of 3, so I pull out 3 groups of 3, which is 3 cubed, which then becomes 27. Alright, this last set, we're also going to be using our rules for exponents. So the first one, I have x to the 1/5 times x to the 7/5. Remember, when you multiply things that have the same base, you are going to be adding their exponents. So this becomes x to the 8/5, which you know from rewriting is the fifth root of x to the 8th. And now, simplifying that, I can pull out one set of x, and I have 3 leftovers. So inside I have x to the 3rd. This next one is similar to the example before. Since it's a negative exponent, I'm going to move it to the bottom of a fraction, so 1 over y to the 3/4. And that becomes 1 over the 4th root of y cubed. Now, we still cannot leave radicals on the bottom of a fraction. I have 3 sets of the 4th root of y. I need a 4th so I can take it outside of that square root. So just like yesterday where we were multiplying by fancy ones, the one that I'm going to use today is the 4th root of y. And you'll see why in just a second. So the 4th root of y over the 4th root of y. On top, when you multiply it by 1, it becomes 4th root of y. On the bottom, we have 4th root of y. The symbols are the same, so we write that 4th root of y. And on the inside, I have y cubed times y, which is y to the 4th. Now I have 4 y's, which will come out. So the bottom simplifies to y. The top is 4th root of y. This next example, once you rewrite it, you should see that it's a problem just like yesterday. Square root is what we have when we have an exponent of 1/2. So it's the square root of m minus 1 over the square root of m plus 1. From yesterday, hopefully you remember that we're going to multiply by the conjugate. So square root of m minus 1 over square root of m minus 1. And again, remember, we take the bottom, but we change the sign in the middle. Now we have to FOIL. When I do that, on top I have m, square root of m times square root of m, which is just m. I have negative 1 times the square root of m, so it's negative square root of m. I have another negative 1 times the square root of m. And then I have negative 1 times negative 1, which is positive 1. On the bottom, remember the reason why I used the conjugate is so I could get rid of those square roots. So square root of m times the square root of m is m. My inner and outer will cancel. 1 times negative 1 is negative 1. So my bottom is simplified. My top, I need to combine these two terms. So it's going to be m minus 2 square roots of m plus 1. So that becomes my new top, just simplified. Alright, and this last example. This one, it's going to actually be easier if I turn them into exponents, so I can use my rules for exponents. So on the top I have 81 to the 1/8, and on the bottom I have 3 to the 1/6. Now, I can't do anything with the exponents unless my bases are the same. Well, 81 can be rewritten as 3 to the 4th. And then I'm going to apply the exponent of 1/8 on that. My bottom is still going to be 3 to the 1/6. When I take a power to a power, I multiply those exponents. So I get 3 to the 4/8, which reduces this exponent of 4/8 will reduce to 1/2. And my bottom is still 3 to the 1/6. Now, before, when we talked about when you divide, you subtract exponents. And if you take 1/2 as my exponent and subtract 1/6, you get 2/6, which is 1/3. So it should be 3 to the 1/3, and that can be rewritten as cubed root of 3. I know I tried to go through some of this really quickly. I'm sorry. If you have questions, you can ask them tomorrow. Please feel free to re-watch this video, and maybe you'll catch and pick up on some of the other information if you didn't catch it the first time. And hopefully you have a good day.